Welcome to AI Frontiers. Today, we explore the engine room of artificial intelligence through a concentrated snapshot of global research. We synthesize 85 papers from the arXiv preprint server, Computer Science Learning category, dated December 24, 2025. This journey examines the push to make AI not just smarter, but smaller, more interpretable, and more trustworthy, moving from statistical limitations to critical clinical applications. A startling revelation emerges about how AI learns. Teaching an artificial intelligence system, "Don't touch the stove," may inadvertently teach it to touch. Warning labels become statistical noise rather than normative instruction. Models learn associations between context and action, not the intent behind commands. This fundamental finding challenges naive approaches to AI safety and alignment, forcing a complete rethink of how values are instilled. This episode presents a day's intellectual output from the global machine learning research community. The 85 papers from the arXiv preprint server represent a focused snapshot of puzzles in machine intelligence. The scope ranges from analyzing tuberculosis genomes to speculating on quantum classical hybrid architectures. The unifying quest is to make AI systems smarter, smaller, and fundamentally more trustworthy. The current research landscape can be visualized as a machine learning metropolis. The soaring skyscrapers are the large language models and foundation models. The critical infrastructure consists of efficient algorithms and robust system designs. The urban planning involves ensuring fairness and interpretability. Researchers are also developing new materials in the form of novel neural architectures. The collective goal is to build a resilient, comprehensible city of AI, not a fragile, opaque labyrinth. A first major research theme is the industrial district, focused on extreme distillation for model efficiency. This involves compressing billion-parameter models down to 1-bit weights. A key paper, Rethinking Output Alignment for 1-bit Post-Training Quantization, tackles this challenge. The goal is to preserve the model's knowledge and capabilities within vastly smaller computational vessels. This enables advanced AI to run on resource-constrained devices like watches, cars, and satellites. The process is analogous to capturing a grand symphony using only 2 notes. The second theme is the transparency quarter, dedicated to moving from correlation to causation. Researchers are building windows into AI decision-making processes. The paper, A Model of Causal Explanation on Neural Networks for Tabular Data, exemplifies this shift. It aims to move predictions from stating what will happen to explaining why it happens. This creates essential audit trails for high-stakes decisions involving loans or medical treatments. The objective is to build systems that function as meteorologists explaining causes, not merely as weather vanes indicating correlation. The third theme is the synthesis sector, focused on world building with generative models. This work addresses data deserts by creating high-fidelity synthetic environments. Synthetic financial data generation for enhanced financial modeling is a prime example. It acts as a flight simulator for economists and traders. These zero-risk environments allow for rigorous strategy testing without exposing proprietary information. The generative model's role expands beyond creating art to constructing realistic, proprietary-free market simulations. A key finding from the day's research is the failure of instruction. In the paper, Learning from Negative Examples by Zogt, Okir, Enkbayar, and colleagues, models trained on warnings reproduced dangerous code 76.7% of the time. Models trained directly on the same code without warnings reproduced it 83.3% of the time, a statistically identical result. Analysis found no distinct don't neuron within the model's neural features. This indicates that large language models act as statistical sponges, absorbing co-occurrence patterns while remaining deaf to human pragmatics and intent. Another key finding establishes a principled partnership for agent design. The paper, An Information Theoretic Perspective on Agentic System Design by He et al., demonstrates that scaling the compressor model is more impactful than scaling the predictor model. A better summarizer or compressor provides richer, more relevant context to the large language model. This approach reduces system cost and latency dramatically. The principle is to invest computational resources in the analyst that prepares the information, not just in the decision maker that consumes it. The paper of the day is VAMP-Net, an interpretable framework for predicting tuberculosis drug resistance. Developed by Aicha Butor and colleagues, it solves a critical life-or-death diagnostic problem. The system predicts Mycobacterium tuberculosis resistance to first-line drugs like rifampicin. Crucially, it provides dual-layer interpretability, biological cause, and technical certainty. Its two-path architecture features a biology detective and a crime scene investigator. The model achieves over 95% accuracy while providing clinicians with actionable audit trails for treatment decisions. VAMP-Net operates through a dual-layer interpretability architecture. Cath1 is a set-attention transformer, acting as the biology detective. It identifies epistatic interactions between genetic mutations, where mutations in one gene influence the effects of mutations in another. This allows visualization of which specific sets of mutations drive the resistance decision. PATH2 is a quality-aware 1D convolutional neural network, the crime scene investigator. It analyzes technical metadata, weighing sequencing quality scores and data confidence to produce an adaptive confidence level for the final prediction. Future directions point toward adaptive cognitive layers, shifting from discrete models to systems of continuous cognition. Research explores models that self-adjust their internal learning rates, mimicking biological neuroplasticity. Papers like dynamic feedback engines aim for robust continual learning without catastrophic forgetting. Systems like MotionTeller fuse wearable sensor data with language models for health companionship. The vision is for AI to become invisible, essential, and dynamically responsive infrastructure, more like the electricity in walls than a library one visits. In conclusion, the frontier of AI research is expanding inward as much as outward. The field actively wrestles with the dual demands of efficiency and interpretability. A key lesson is that pure statistical learning has fundamental limitations regarding intent and normativity. Real-world applications, especially in clinical settings, demand accountable, evidence-based reasoning. This work is as much about philosophy and ethics as it is about mathematics and code. The listener's engagement and curiosity are part of what will ultimately shape this technology's trajectory. This presentation was created through AI synthesis and expert review. The narrative content was synthesized using the GPT DeepSeek model, specifically DeepSeek Chat. Text-to-speech synthesis was performed via OpenAI's TTS technology. Visual concepts were designed for stable diffusion image generation. All synthesized content was reviewed by a human expert. The references are drawn from 85 papers in the arXiv preprint server computer science learning category. Dated December 24, 2025. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.